When you're asked to solve this problem, you don't need to skip to the next question. What you have is a 2 by 2 matrix on the left hand side and a 2 by 2 matrix on the right hand side with an unknown. In this case, you are asked to find the value of x. And so what you need to do is to find the product of the right diagonal and then just subtract that from the product of the left diagonal. This is the diagonal here. This is the left diagonal and this is the right diagonal. So you find the product. Product means you multiply. So multiply this 2 times 3x, that's 6x, minus 5 times 3, 15, is equals to 4 times 2x, 8x, minus 3 times 1, and that's 3. So you simplify 6x, you take 8x to the other side, becomes minus 8x. When you take 15 to the right hand side, becomes plus 15 minus 3. And so this is minus 2x equals to 12. And the value of x is 12 divided by minus 2. And so this gives an answer of minus 6. And that's option A. You see, you don't have to skip. You just solve it and you move to the next one. So let's move on to the next problem. The next problem here is also a question on matrix. It says find the inverse or the inverse of matrix n 2, 3, 1, 4. This is also a 2 by 2 matrix. I call it a 2 by 2 matrix because it is made up of 2 columns and 2 rows. This is the column and this is the row. 2 columns and 2 rows. So what is the inverse of n? Inverse is represented with this symbol. This represents inverse. So what is the inverse of n? To find the inverse of n, the first thing we need to do is to get the determinant. The determinant of n. Let us find the determinant of n. The determinant of n. And that is similar to the last question we solved. So to find the determinant of n, you multiply diagonally 2 times 4, that's 8, minus 1 times 3, that's 3. So we get 8 minus 3 is 5. So the determinant is 5. Having found the determinant, what you need to do next is to swap the left diagonals and change the sign of the right diagonal. You know, left, this is your left diagonal and this is the right diagonal. So we're going to swap this. You swap the left diagonal. So what you have here, this is 2 and this is 4. So by the time you swap these, you have 4 and then you have 2. And then you change the sign of the right diagonal. This becomes, the sign there is plus 1. And so when you change it becomes minus 1. The sign there is plus 3. And when you change it becomes minus 3. Essentially, the idea behind this is that the inverse of n times n itself must be equals to the identity element. So there is an idea behind all of this. But what you need to know is you find the determinant and then you swap the left diagonals, the numbers, and then you change the signs of the right diagonal. If you have a minus before, then it becomes a plus. And when you have a plus before, then it becomes a minus. All right. So having done this, the final thing to do is to multiply by the inverse of the determinant. The determinant is 5. So the inverse of 5 would have given you something like 1 over 5. So you multiply this by 1 over 5. So you have a 4 minus 1. Here I have a minus 3. And then you have 2. So this represents the inverse of n. Remember, the process, first of all, is for you to find the determinant. When you find the determinant, the next thing is to swap the diagonals and then you change the sign of the right diagonal. So we have this as the answer, and that would probably be option D. Option D. So let's go on to the next question. The minimum point of the curve. Find the value of x at the minimum point of the curve. So you need to pay attention to this information here. To find the value of x, you must understand first of all that minimum point of a curve, you're talking about the turning point. Your turning point could be at a minimum level or at a maximum level. But you must understand that at the minimum level, the turning point, the gradient is 0. The gradient is 0. The gradient is also 0 at the maximum level. So the first thing to do here to identify the value of x is to find the gradient function. So the rate of change in y with respect to the rate of change in x. So we differentiate each of these. This is 3x squared plus 2x minus 1. When you differentiate a constant value, you get 0. I'm going to substitute my gradient function at 0 because at the turning point, the gradient is 0. So here I have 3x squared plus 2x minus 1. I have a quadratic equation, so I'm going to solve this in order to get the value of x. Now you're free to solve quadratic equation using any of the methods that is best comfortable with you. So solving this, I'm going to solve this using a factorization method. The two factors are plus 3x and minus x minus 1 equals to 0. So when you factorize this by grouping, I would have an expression like this. So this is minus 1 into x minus, okay, plus 1 equals to 0. So my two factors are x plus 1 and 3x minus 1 equals to 0. So the values of x equals to minus 1 or x equals to plus 1 over 3. Now you need to pay attention to this. Now this has given us the value of x at the turning point. But to know the exact value of x where you have the minimum point, to know the exact value of x where you have the minimum point, we will need to find the second derivative of that function, which is the square y over the x square. Now we're finding the second derivative of this function, 3x squared plus 2x minus 1. So the second derivative will be 6x plus 2. So we're going to substitute the value of x here. Whatever we get determines the minimum at the minimum point and at the maximum point. But take note of something. If the second derivative, having substituted the value of x, if you get a value greater than 0, then that means you are dealing with a minimum value. And when you substitute the value of x and you get something less than 0, then you are dealing with a maximum value. I mean, this is how the curve will look like exactly. Again, this second derivative gives you a better picture of how the curve will look like. So substitute, let's put x as minus 1. I have 6 times minus 1 plus 2. So this is minus 6 plus 2, and that is minus 4. Now at this value, this simply means I would have, this is a value less than 4. That means I will have the curve like this. And in this case, that means I'm dealing with a maximum value. But remember, the question says, what is the value of x at the minimum value? Please click on the subscribe button, follow, share, and leave your comment. Let's substitute to find the value, to get what, okay, let's substitute the value of x again here now. Put x as 1 over 3. I have this, I'm substituting in my second derivative, 6 times 1 over 3, then plus 2. So 3 here 1, 3 here 2, plus 2, and this is 4. This is a value that is greater than 0, and that tells us that the curve will look like this. And if your curve is like a value like this, then you're talking about a minimum value. So the value of x at the minimum would be 1 over 3. So the correct value here is 1 over 3. And that is option A. 1 over 3. Thank you for watching. I'm going to see you in the next class.